Well, good morning and welcome to Nani Notes. Today's topic is exponents. This is for you Algebra 1 students, or pre-algebra, wherever you may see it. My last year I taught Algebra 1 and I found that we had to go over the basic rules. You'll find this in Chapter 8 of the McDougal Littel textbook. That one that appears in the upper right corner there. If that's what you got. If that's your textbook, the one with a kayak on it, Chapter 8 is all about exponents. So we're going to look at just the basic definition, the simplified definition of exponents, and we're going to look at these four rules because it's a law. We're going to hold off on the zero and negative because that just gets to be too much. I usually cover this in one class period and then we do some examples. So here we go. So let's hit it for some basics on the laws of exponents. Ready? Let's go. Okay. In our laws of exponents, exponential form, and we're going to say a raised to the m power. We like to think of this where a is called the base. Now, we've talked about this before with our base 10 numbering system, and m is the exponent. One simple way of thinking of it is, if I write this down, 5 to the 4th power, 5 times 5 times 5 times 5, I can say the exponent tells us how many times to use the base as a factor. So the base is 5. It is used as a factor 4 times. 5 times 5 times 5 times 5. Pretty straightforward, right? I know you guys all knew that. But stay with me. It's the law. Now, let's look at a product of powers rules. Now, this is an interesting one. If we multiply two exponents with the same base, all right, we're going to copy down that base and then add the exponents. See, and I have my students write these rules down as we're going. So if you're teaching this class, maybe you'll have them do something similar. So, here we go. Said very simply, a to the m power times a to the n power is a to the m plus n. This is a pretty abstract way of seeing it. So it's always best if we look at an example. Okay, well, how about 3 to the 3rd power times 3 to the 4th power? Now we can expand this and we can see, okay, I've got 3 to the 3rd power is 3 used as a factor 3 times. The base there, that is, the base 3 is used as a factor 4 times. Altogether, how many times are we using it? Well, we're using it 7 times. And that makes sense. 3 to the 3 plus 4 power, 3 to the 7th power. And you can just count them all. Look at that, there's 7 3's there. All right, let's try this. How about this? First, are they the same base? Yes, they are. I suppose I should mention it. It's got to be a non-zero base. And we'll have that restriction there. And we're going to say, well, hang on. Well, that's going to be z to the 5 plus 3 power. Easy squeezy. How about this one? Do we have the same base? The answer is yes. So you're going to write it down. The base is d. What's the exponent? 2 plus 4. Oh, okay. That's going to be d to the 6th. All right, a little bit different here. Now, students might get caught on this one. I've got w to the 5th power times w. Is that the same base? Yes, the base is w. Now the exponent on that over here is 5. What's the exponent there? Oh, there isn't one. Well, there is. How many w's do you see there? Well, I see one, Mr. Bench. Well, that's because that is w to the 1st power. So w to the 5 plus 1, or w to the 6th power. Okay, let's try another one. Now we're cooking, because we're going to add something new here. Now, what is the base? The base is x. The base is not 3x. There's no parentheses there. The base here is x. They're the same base. Well, what about the 3 and the 4? Well, those are, we're going to call them something else. Those are the coefficients, right? And you got that written down, I know. So let's, they answer the question, how many? How many x to the 4ths do we have? How many x to the 7ths do we have? So let's copy down the base, right? That's going to be x. 4 plus 7 is 11. But what do we do with the 3 and the 4? They're just plain numbers. We're still multiplying them. They tell us how many. So I'm going to, notice I copy down the x. I add the 4 and the 7, x to the 11th power. But I multiply the 3 and the 4. They are coefficients. I'm getting the hang of this. How about this tricky one here? First off, the base here is s, the base here is t. Same base? No. But what about the 2 and the 3? Well, they're coefficients. So can we do something there? Sure. We can multiply the 2 times the 3. But, you know, s to the 3rd power, t to the 5th power, we're just going to put them next to each other, and we will refer to that as an indicated product. So right there we have an indicated product of the whole number 6, the coefficient, the s cubed, and the t to the 5th power. Nice. All right, well there's product of powers. How easy is that? Let's move on to quotient of powers. If we can multiply, I guess we can probably divide. Can we do this? Okay, we divide two exponents with the same base. We copy down the base and we subtract the exponents. Okay? Or, as we like to write in our abstract form, a to the m power divided by a to the n is a to the m minus n. Keep that in mind. We're going to demonstrate the zero and the negative exponent using this again on another video. How about this? Well, if I follow the rule, that's 7 to the 7 minus 5 power. That's 7 squared, 49. But let me show you that in expanded form so you can prove it to yourself. And it just makes sense, doesn't it? Because I've got all these 7s, really lucky, and these divide out. 7 divided by 7 is 1, and I can just divide out all these 7s. And what am I left with? I'm left with 2 7s in the numerator. So there, just by expanding, we can see that. Okay, you got this. Same base, copy down the base. What's the base? Z, or as we like, some of my class say Z. 5 minus 2, z to the 3rd power. How about this one? Same base? Yes, it is. Copy down the base. A to the 9 minus 3 power. 9 minus 3, a to the 6th. Nice. How about this one? Hey, we did this last time. We can't fool us. We got that W. That W in the denominator is W to the 1st power. W to the 5 minus 1 power. W to the 4th power. How about this one? Ruh-roh. Well, we got multiple things going on here. Well, first off, do we have the same base? Yes. X to the 9th divided by x to the 7th. Copy down the base. X to the 9 minus 7 power. That's x squared. What about the 12 and the 4? Well, you know, you're just going to divide those just like you would normally. 12 divided by 4, well, that's 3. So this is going to simplify to 3x squared. If you were confused, well, you could expand it. But I don't think you have to. I think you got this. How about this guy? Ooh, s cubed over t to the 5th. Same base? Nope. But we can simplify it just a wee bit. And that's as far as we can go with that. Okay, all right, we're getting the hang of this. So we can multiply. When we multiply, we add exponents. When we divide, we subtract exponents. How about when we raise a power to a power? So we're going to take a power and raise it to a power. Now we are going to copy down the base and multiply exponents. A to the m power raised to the n power is a to the m times n. Or 6 to the 4th, and I'm going to raise that to the 3rd power. Well, let's expand this so it makes sense. So that really means I'm using the 6 as a factor 4 times here, 4 times again, and 4 times again. All together, I can just say, now I can add them all up. I've got 12 of them. Or 6 to the 4 times 3 power. That's 6 to the 12th power. So let's try it. Z to the 5th, when I square it, it's z to the 5 times 2. Okay, try this one. A to the 9th power, and I cube that. A to the 9 times 3 power, 27th power. I can get where this is going. Now this one's a little bit funny. What's w to the 5th power times w? Well, hang on a second. Well, that's, I'm not raising it to, why is that even in there? Hey, that's from the last one. Sorry about that. Dang it. Oh, here we go. I think I messed up there. I should have had this on the last, because this is not raising a power to a power. Should have been on the previous page. So here we go. We can say x to the 9 plus 7 power. This is a product of powers. I guess I wrote it there to show the difference. I can multiply the coefficients. So I've got 15x to the 9 plus 7 power. I must have done that for a reason. That's why. Let's look at the difference between that and raising this entire expression. 3x to the 5th. We're going to raise that to the 3rd power. Notice the parentheses. Please excuse my dear Aunt Sally. We are going to raise x to the 5th to the 3rd power. So that's x to the 5 times 3 power. But that 3 is also being cubed. So what are we going to do there? 3 times 3 times 3. That's going to be 27. Notice the difference between this, that is a product, and this of powers, and this is a power of powers. And watch out for those parentheses. The entire expression inside those parentheses is being raised to that power. You might call that the distributive property. I guess you can call it this. Okay, we're going to call it the distributive property. We'll do some examples on the next page. Ready? Yeah, here we go. We raise an expression to a power. We distribute the exponent to each factor. So, ABC to the n power is a to the n power, b to the n power, c to the n power. Note the parentheses. Okay, let's try it here. And again, we are going to, every term inside there, or every factor inside there, the 2 must be raised to the 3rd power. A to the 3rd raised to the 3rd power. And the b is raised to the 3rd power. Now, if you don't know that 2 cubed is 8, well, you figure that out. 2 times 2 is 4, 4 times 2 is 8. If we were to expand this, I can expand it like this. And I can see the 2 used as a factor 3 times, the a to the 3rd power used as a factor 3 times, and the b used as a factor 3 times. 8, a to the ninth, b cubed. Okay, let's try this one. Again, we're going to distribute. So I've got each of these factors is being squared. B squared, squared again, 2 times 2. Hey, what would Barney say? We're going to say 2 times 2 is, oops, I missed it. What did I do there? All right, well, hang on. I guess I'm going to have to go old school on you. Sorry about this. I must have messed up there on the recording and setting this up. So I'm going to put down B. I'm going to have to use my, and I'm going to say 2 times 2 is 4. And then I'm going to put in another Z, 5 times 2 is 10. So we're raising a power to a power, and we are distributing. Okay. And let me see, we've got that one, and we've got that one. Okay, let's crank these two. Let's crank these out. Again, a squared, that's going to be a, copy down the base, the 2 times 3, or the 6th power. And then we're going to make our next base is c, again to the 2 times 3, or 6th power. How's that going for you? Now, here we go. We've got 10 w to the 5th. We're going to square it. Now, I could write it this way. I mean, I could say 10 squared. We all know that that's 100, but we'll just write it like that for now. And then we'll say w, the big W, to the 5th power. 5 times 2 is 10. Now, of course, I would clean that up and I would call that 100 w to the 10th power. Nice. Okay, we're almost done with this. So let's keep this momentum going. Let's do this on quotients. Quotient, again, we know that that is division. We're going to distribute. In the abstract, we can distribute the n to both the a and the b. Here's an example. And let's expand that example. And you can see, just like we did before, a to the 3rd power used 3 times is a to the 9th power over b to the 3rd power. So let's go ahead and try this. Can we simplify that? Sure we can. We can say b to the 3 times 2 power over c to the 2 times 2 power. Again, all we're doing here is distributing. What are we going to do here? Whoa. Now, there's a couple ways you could go here, because you see this already is not in its simplest form. We're going to have to carry the restriction that c can't be 0, but I could simplify. I could do the division first and then raise it to the power. Or I could do it this way. I could just a to the 2 times 3 power, c to the 2 times 3 power over c to the 3rd power. And then I can further take the quotient powers, c to the 6 minus 3 power. And that's going to be a to the 6th, c to the 3rd. Honestly, I could have resolved inside the parentheses first. I could have divided out the c. I would have had a squared c, and I would have ended up with the same result. Okay, just one more example, and I'll leave you to it. Ooh. Now again, multiple ways we can go here. We could resolve. We could say, well, 10 divided by 5 is 2. 2 squared is 4. Or we could expand it. What? Somebody needs, I need a new editor. First off, well, let's clean this up. Let's pretend we didn't see that. We're going to say 100. I'm going to square the 10, and this will be W to the 10th power. And this goes away. And then I could say that 5 squared is 25. So that coefficient would be 25. C to the 2 times 2, or 4th power. And you see, we could have gone that way. But then we could take the 100 divided by 25, and I still get 4. So you see it's consistent. It is consistent because either way, I'm going to get rid of, I can divide this out, and I'm going to have 4. So whether I divide it inside the parentheses or expand it and divide it afterwards, I still got the same quotient. And I think that's going to be all for now. Do some examples in the textbook, follow your teacher's instructions, and as always, thank you for watching 99.